All right. This is our lesson for Learning Objective 1.6. We are continuing to move towards quadratics. We're not going to work with any graphs today, but we're going to work with quadratic functions, and in particular, we are going to practice factoring quadratics. Okay. You see in the objective it says to factor trinomials. Okay, that just means a polynomial that has three terms. The general form of a quadratic is ax squared plus bx plus c. It can have an x squared term, a constant term, and a term with an x in it. So it's just a fancy way of saying quadratics. Okay? I'm going to go ahead and scroll down and look at our first slide. All right. You really can't talk about factoring quadratics without talking about x-intercepts, because that's really the purpose. That's why we do it, is because it makes it easier to find x-intercepts. Quadratics can have 0 x-intercepts, they can have 1 x-intercept, or they can have 2. Can't have more than 2. All right? And in fact, just a little pattern to point out here. You can have at most 2 because a quadratic is what we call a second-degree polynomial, meaning that the highest power in the equation is x raised to the second. Okay, there's no third power or fourth power. That tells us the maximum number of x-intercepts it can have, and in this case, it's 2. Well, how do we determine what they are? Well, that gets back to factoring. Factor, kind of running out of room here. Set equal to 0 and solve. That's the idea for finding x-intercepts. All right. So over here, I've got myself a quadratic equation, a quadratic function. X squared plus 7x plus 2. These are the cases when a, which again is that number in front of x squared, when that's 1. Okay. Here our factoring techniques are fairly straightforward. You take that last number at the end, and I simply want 2 factors of 12 that add up to 7. Okay, this is the part of factoring that can typically take a little bit of time. Okay, be patient with it. You'll probably find that more often than not, it might take you more time than me to think of the factors, and then I have an idea of what they are before I put together the video, so I don't have to sit here and think about what they are for 5-10 minutes. Not that long. I'm exaggerating, but in the video, it very well may go faster than what it will take you. And that's okay. So my 2 factors would be x plus 3 times x plus 4. Okay, if the instructions just told me to factor, I'd be finished. But if it was to find x-intercepts, then of course I would take each factor here, the first one being x plus 3, set that equal to 0, and set x plus 4 equal to 0. These are much smaller, more manageable equations to solve by splitting up into 2 factors. -3 and -4 are the two x-intercepts. All right. Second example here. Try this one on your own. Obviously, you can feel free to take what you have and check in with me. But for the sake of time, I do want to get to some other examples, particularly when n is not 1. Okay. All right. Here, this is actually another example where a is 1. Okay. I'm not as far as finding the x-intercepts go. I'll work this one all the way through. I'm looking for 2 factors of -10. Okay, and what I should notice here, if I'm looking at factors of a negative number, I got to keep in mind that my factor one has to be positive and one has to be negative. If I'm going to multiply these 2 numbers and get a product that's a negative number, which I do in this case because I'm looking at factors of -10. Okay. Now negative 5 and 2, that's not going to add up to positive 3. However, negative 2 and 5 will do the trick. So there we factored. To find x-intercepts, I take each factor, set it equal to 0. And again, we find ourselves with two equations here that are fairly manageable to solve. First one yields a solution of x plus 2. Second one gives us a solution of x equals negative 5. Okay, so here we're taking a quadratic, again factoring it, in order to find its x-intercepts. Okay, so that's all great and everything. Pretty straightforward process here with looking at the factors of the last number that add up to the middle number. Okay? What if x is not 1? Okay? The very first thing you should check, okay, when a is something other than 1, try to find a common factor. Oops. Try to find a common factor. Okay, what this is going to do for us is we're going to do everything we can to make the numbers in the equation as small as possible. Smaller numbers generally means fewer factors. Fewer factors means there's fewer possibilities for how the factors could break down. That means less time. The smaller the numbers are, the easier it is. Okay, so I look here and see that's divisible by 2, that's divisible by 2, and so is that. So I could rewrite this quadratic with a common factor of 2 pulled out, and I have x squared minus 6x minus 7, and I can just go ahead and factor what's in the parentheses. This is now another case where a is 1. So it would be just like the previous examples that I've done. Looking for factors of negative 7 that add up to negative 6. That would be negative 7 and 1. That's been factored completely. Don't forget there is a 2 out there, even though it has an impact on the shape of the graph, but it does not have an impact on the x-intercepts. Okay, which is why I can take out that common factor, make the numbers a little bit more manageable, and then proceed from there. All right, so here the instructions are once again to factor. A equals 3, so it's greater than 1. I can try to take out a common factor, but you are not going to have any luck because 3, 10, and negative 8 do not have any common factors. Okay? What I have to do here is start the process of breaking it up into two factors, but what you notice with the 3x squared is those first two terms are going to break up to 3x and x. Okay? Now I'm still going to look at factors of negative 8. However, I'm not going to find any that add up to 10, and that's not going to work. Okay, that little trick of looking for factors of negative 8 that added up to 10, that would only apply if a is 1. That's why it's kind of a significant thing here to look at some examples where it's not, because the process is a little bit different. Now the first factors that come to mind here to me are negative 2 and 4, negative 4 and 2. Okay. One thing I can do here is do a little bit of guess and check. You have to remember, if I want to go back from this factored form back up to the original equation, I can get there by that process called FOIL. And now because I'm looking at factors of negative 8, and I split up 3x squared as 3x and x, as far as the FOIL process goes, I don't have to worry about the first or the last. Okay, if I'm, foiling this, I know the first is going to be 3x squared. Okay, and if I substitute any of these factors in for the rest of the expression, I know from the last terms, right there, okay, it's going to be minus 8. It's getting these middle two components of the FOIL to match 10. That's what I have to be concerned with, okay? Now, this is another process that might take you a little bit of time. It might involve a little bit of guess and check. But if I were to do 3x minus 2 and x plus 4, what I notice is when I do the outer terms and the inner, 3x times 4 is plus 12x, and negative 2 times x is minus 2x, and that gets me to the 10x that I'm looking for, okay? It takes practice. It's not as straightforward as when a is 1, and you might find that the first pair of factors that you check when you FOIL it, it doesn't match. It doesn't work out. Well, try something different. Maybe the numbers have to switch places. Maybe you pick the wrong set of factors. Okay, be patient, and try. Try something. That's oftentimes is the key. Is just try something, see if it works. If it doesn't, move on. This brings us to 1.6 day 2, and that's where we're going to call it quits for day 1. Just a little preview as to what's coming. We are going to continue to factor and throw in the quadratic formula and practice another new technique called completing the square. All right, any questions on day 1? Make note of those, and let's talk about them more.